All right, guys, in this lesson here, we're going to talk about the transfer of charge from one object to another and also the conservation of charge. So pretty much what we have is we're going to be looking at when one object acquires a charge and then it could give that charge to something else and how charge must be conserved. All right, so and how charge is distributed among different objects, distribution of charge. So what I want to do is first I'm going to look at a sphere. And this is a metal sphere. And in that middle sphere, it has 2 protons and 2 electrons. So if I have 2 protons, which have a positive charge, and I have 2 electrons, this object would be said to have 0 coulombs of charge, or it would be neutral. Now, if I had some object with a lot more charges in it, so let's say I had 5 and I had 1, 2, 3, 4, 5 electrons. They would be distributed evenly throughout, meaning all the electrons don't hang out over here and the protons don't hang over here. But now if I were to bring an object near this object that had a net positive charge, so I have a rod and it has a net positive charge. As I bring that object close to this object, the negatives are going to be attracted to the positives and it will cause these objects to distribute differently. What it will say is that 1, 2, 3, 4, 5, these protons will be repelled, and then I'll have 1, 2, 3, 4, 5 electrons that get attracted to this, okay? So charge is distributed evenly, but when another charged object is brought by this object, they will distribute themselves evenly, okay? Now, if those objects were to touch, so I have the same object with 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. If I were now to bring that rod over, and that rod touches this sphere that was once positively charged, these 2 objects now become one. And when I say become one, I mean they become one for the sake of charge distribution. All right? So what's going to happen now is because I can now kind of consider this to be one object, I had before on this, I had 1, 2, 3, 4, 5. I had 6p, and I had 1, 2, 3, 4, 5, 6e. And now over here, I had 4 p's and no e's. So now over here, I'm going to have now a total of 10 p's, which is going to be the 6 plus this. And then I'm going to have 6 electrons. All right? I'm going to have 6 electrons. So the total charge is now going to be 4, where this was once neutral and this was plus 4. Now this is going to be plus 4, and that's okay because charge is conserved. So the total charge before 0 plus 4 has to be equal to this after. Now here's where things get a little bit interesting. If I now take the rod away, they will go back to being 2 objects once again. But now the charge will stay distributed. So now if this was the total charge that distributes itself evenly, when I pull them apart, this is going to have a plus 2 and this is going to have a plus 2. And we know that electrons can't move. I mean, we know that protons can't move. So now when I had those 4, how am I going to make that negative? Well, what happened was 2 electrons from here jumped onto here and stayed there. Where now I keep the same 6 electrons here. 2, 3, 4, 5, and 6. Now this guy has lost 2 electrons. So now it only has 1, 2, 3, 4, which would now leave an excess of plus 2. So this shows that electrons will move and I become charged. So this guy went from 0 to 2 by losing electrons. This one went from 4 down to 2 by gaining the electrons. So this is where that charge is conserved. Electrons can move back and forth, but the total charge always must be the same. All right? And a very big note, only electrons move. All right, so this is that distribution of charge. Now you'll see examples, and you'll see some in my examples too. Let's say I had 3 spheres. Okay, so now I have 3 spheres, A, B, and C. And we'll say this one has a charge of 0. This has a charge of -9 coulombs. And this has a charge of +6 coulombs. And the question will say, what will the charge of B be if I touch them and pull them apart? Okay? So now what happens when they touch, they become one object, as we just discussed a minute ago. So now, if this is 0, this is -9, and this is +6, when I take the sum or the net charge on this, I see that there's a net charge of -3 coulombs. And that -3 coulombs is going to be distributed evenly to all of these. So now they're touching. All right. Now I pull them back apart. They will each now have a charge of -1 coulomb. Because I have a net charge of 3 that needs to be distributed amongst 3 objects. Okay? So what happened was, and this is kind of a follow-up question, the charge of B went from -9 to -1 coulomb. So the follow-up question would be, did it gain or lose electrons? Did this object gain or lose electrons? Well, did it become more positive or more negative? It became more positive. It became more positive. Therefore, it gained a positive charge, and the only way I can gain positive charge is to lose electrons. Okay, so if we look at all of these, this went from 0 down to -1. This gained. This one lost, and this one became more negative. This gained the most. All right, and guys, you can do this, and you can touch as many objects as you want together. But just remember that when they're touching, it's super important that when they're touching, they are one, okay? And the objects can move around inside. Like the protons can move, but they cannot jump, all right? And that's the difference. You might see an example if I have 3 spheres, okay? And each one of these has a net 0 charge. If I were to bring a positively charged rod over here, what would happen in these 3 spheres? Well, what would happen is the negatives would attract, okay? The negatives will attract, and the positives will come to the far side. They didn't jump, they just moved, and they can do that inside their own sphere. Okay? But the difference is, if they are touching, things would be very different. If I had the same spheres, okay, and then I brought them together and I touched them. Sorry, circles are my strong point. Okay, and if I bring a positively charged rod by them now, All right, they're all touching, so now they're all one. So now all of these can move amongst one another, and they can look like this. Okay, all the electrons will get pulled towards, and then if I were to separate them back, this would now have acquired a positive charge, and this would be left all positive. So this would become more negative, and this would become more positive. Okay, guys, and let me be clear. The electrons, the protons did not jump. These are excess, all right? So these are excess electrons. I hope that clears everything up, guys. If you want, look at the sheet down below. I post all the solutions and some worksheets as well. And if you have any other questions about how charge is transferred between objects, just leave a question down below, and I'll see you in the next one.